Welcome to this next session of special theory of relativity. In this session, we are going to see about time dilation and length contraction. As we have seen in the previous classes, the two principles of theory of relativity, which are all the physical laws are same in all the inertial frame of reference, and second principle, that is the velocity of light is constant in all the inertial frame of reference. Okay, according to these two principles of special theory of relativity, only physical laws and velocity of light are absolute. Only these two things are absolute, whereas all the other things are relative. To understand this properly, first let us consider what we used to consider relative and what we used to consider absolute according to Newton's theory of relativity or Newtonian relativity. According to Newton's relativity, we used to consider mass, time, space, time interval, that is, and space interval as absolute. Also we used to consider all the mechanical laws, not the all physical laws. We have understood the difference between mechanical and physical laws. So in Newton's relativity, they used to consider all mechanical laws to be absolute, that means independent of observer, whereas displacement, distance, position, speed, velocity, all these things were considered to be relative, that is dependent on observer. Now what Einstein's principles tell us is that only two things are absolute, that is all the physical laws and velocity of light. Velocity of light are absolute, that means independent of observers, whereas all the other things that are related to motion are relative, that is mass is relative, time interval is relative, space interval, that is length, is also relative. In addition to all these things, displacement, distance, position, speed and velocity, all these things are relative according to the two principles. Now we have already seen Lorentz transformation equations which tell us the relation between time instants. T dash is equal to t minus xv divided by c square divided by 1 minus v square by c square. These equations are for time instance. Same way we have got equation for the length also, L, or we have got equations for the position also, not actually length. We have got equation for the positions. X dash is equal to x minus vt divided by square root of 1 minus v square by c square. Now these equations are for time instance, this is for time instance, and this equation is for position. This equation is for position. So these two equations tell us that the time instants are relative and the positions are also relative. But we have to still derive equation for displacement, speed and velocity. That is what we are going to do. Now before we go to the derivations of lengths and derivations of displacement, first we will have to consider an important concept which will help us to understand the applications of principles of special theory of relativity, that is proper and improper frame of reference. What is a proper frame of reference and what is an improper frame of reference? To understand this properly, what we would do is we will consider let us say this is a train which is moving with certain velocity v, and there is an observer who is standing on the ground observing this train. Now if we consider this frame of reference as S, if we consider this frame of reference as S, According to this observer, let us call this observer as observer A. According to this observer, the train is moving in right direction or right hand with a velocity v. Now, if we consider another frame of reference, where is that frame of reference? That frame of reference is moving along with this train, with the same velocity as that of the train. That means it is moving with the same velocity as that of the object. Now, if you consider this frame of reference and an observer in this frame, let us call this observer B, and an observer in this frame, then according to B, the train is at rest. So, now try to understand in which frame of reference. Let us call this frame of reference as S dash. In S dash frame of reference, the train is at rest, whereas in S frame of reference, train is moving with velocity v, and that velocity is uniform, because we are talking about inertial frame of reference. So this S dash frame of reference is called as proper frame of reference. This is called as proper frame of reference, and S frame of reference is called as improper frame of reference. S frame of reference is called as improper frame of reference. So B's frame or S dash frame is proper frame of reference, whereas S frame is improper frame of reference. To define this, a proper frame of reference is that frame in which the object to be observed is at rest. Whereas improper frame of reference is that frame in which the object to be observed is moving with uniform velocity. So this is what is proper frame of reference and improper frame of reference. Now why is it important? Because this helps us to differentiate between one frame to other frame. If we would consider only the observer A and observer B, according to observer A, B is moving, and according to observer B, if he sees outside, he will be moving forwards, but what will he see is that A is moving in backward direction with velocity v. So the problem comes is that who is actually moving? If we depend on the observers, we cannot say who is right. That is the problem because of relativity. According to observer A, B is moving, and according to observer B, A is moving. So that we are able to differentiate between these two frames, we have introduced this concept of proper frame and improper frame. A proper frame of reference is that frame of reference in which the object to be observed is at rest, whereas all the other frames of reference in which the object to be observed is moving are called as improper frames of reference.